After the introduction, Martin Holly will give an introduction and live demonstration of the THERMOS tool. After that, Simon Neeson will tell something more about the task force heat transition in the THERMOS support the local and government. Rita Ehring will tell something more about the relevance of the THERMOS in the context of the heat planning in Germany. Then we'll have the breakout sessions. You automatically will be divided in several groups. And after the breakout session, we get to this plenaire session again and is able to ask some questions. And we close with the feedback round. I would like also to tell something more about the Task Force Heat Transition project. It's an Interreg project which started in 2019 and will be ended in 2022. The aim is accelerating the heat transition in the German-Dutch border region, as you can see in the map. And we want to support local authorities and other stakeholders to implement specific solutions to a local level. And as you can see, these are our project partners, and we are also funded by the other parties you can see on the right. So this is the team from THERMOS. This is Carsten Rotballer, Martin Holly, and Rita Ehring. And I would like to give the floor to Carsten.
Yes, thank you very much, Thiago. I'd like to maybe use my screen to share also visually some components of THERMOS. And by that, also would like to very much welcome everyone. Here it's a pleasure to present to you one of the softwares that we have been engaged in developing in facilitating stakeholders from ICLEI's side. My name is Carsten Rothballer. I'm working at ICLEI, Local Governments for Sustainability, the European Secretariat based in Freiburg in Germany. And with this short introduction, I wish to spread to you also the, as we say, love about THERMOS, because it's a very special software, and you can indeed fall in love even with software tools like this. Heating and cooling is one of the most crucial parts in order to eventually accelerate the energy transition as a whole and connect the different energy sectors. It's a crucial tool, and THERMOS can be part of that transition and accelerate. ICLEI is of course not the only one who has developed this software. In lead, it was the Center for Sustainable Energy, but there were many other partners that have been involved in this Horizon 2020 project. Within this framework, the THERMOS software was developed. We had two universities, Aalborg University and Imperial College London, that helped us here. Also consultancies and energy experts, institutions like Dena Creare Cape. And then we had, because the focus was on how to help cities most of all in the first place, here with this software, we had 8 different cities across Europe here involved in sharing their needs, guiding the development of this tool, and that's why it is so also quite based on city needs and driven by cities. It's, as I would say in a nutshell, it's an optimal solution for 4 key scenarios, which is the expansion of existing district heating and cooling grids. It's also a wonderful solution to identify local energy demands for known energy sources, finding out the best piping, the best route for any pipe work. It's a solution for optimizing the network to link it with available energy sources, also waste energy sources, renewable energy sources, and it provides you with the opportunity to single out different options that you can, how to plan best your district heating and cooling system. It has many benefits. We will talk about this today more in depth, but maybe one benefit to highlight, which I find quite interesting. Through the visualization, we find that this is, we are enabling different stakeholders to participate, political decision makers, energy consultants, in dialogue with municipal technical staff, universities, and so on. So different stakeholders with different levels of expertise, and through the visualization, entering into a dialogue to decide about the best and optimal solution on local thermal networks. So there are many stakeholders that this tool is for, local authorities and regional authorities in the front, but soon we realized actually utilities, research, academia, project developers and consultancies, they were also at the very core and heart of this software. So I'm open to hear your thoughts today as well, how to use THERMOS within your perspective and application. Last but not least, I would also quickly mention that we have along the process tried to build up trust using the software, having validated it through various universities, and also engaging experts on an advisory board level, but also through our ambassador and train the trainer program, being able to we're able to bring in different perspectives and knowledge, and to the benefit of this software, which is now be ready. It's an open source software ready to be launched and released by the end of this month. So stay tuned, and we are looking forward to this very workshop. I hand over now to Martin.
Great, thank you very much, Carsten. I will just share my screen. Okay, hopefully you can see the a login screen there with THERMOS. Yeah, great. So just to give you a little bit of context and background as to how we got to this point. CSE, who I work for in the UK, we've been working on how to decarbonise heat at a local level for a number of years, and it really started with us developing a methodology for heat mapping, and we produced the London heat map in the UK and the national heat map. So we developed the methodology for that, but that in itself did not address the problem that once you have a heat map and you understand your heat demands and the distribution of those, then you know what kind of network is most appropriate to go there. So we were then fortunate enough to have the opportunity to develop a tool along with 14 other partners, as Carsten has just explained, for the THERMOS project as a Horizon 2020 project. And so nearly 4.5 years later, we've now arrived at this point where we have this tool, and the project finishes at the end of the month. So yeah, we're at the stage now of just finalizing things, but I don't have much time now to go through this, so hopefully I'm just going to give you a brief overview and of how it works and the basic process, and we'll have time after to answer questions, and we can discuss more in the breakout sessions. So I'll just get on. So what you can see there is the kind of the first page you come to with the THERMOS, really. It's a login page, and you can see, first of all, it's a web application. So this is publicly available, free to use. And what we'll do is we'll go straight in. You can just register with your email address. And what you see there is just a bunch of projects which I've been working on recently. So each one of these boxes represents a project in a specific location, and there might be a number of maps within each of those projects which contain different scenarios for heat networks as well. So what I'll do, I won't create a new project for the purposes of this demo. I'll go on one that I've created earlier in this one. And you can see that there's a number of maps here which have been created. But I'd like to show you the process of creating a map, which is the first thing you do with THERMOS. And I could do this just by clicking on map here. And you just get prompted to name a map. So I'll just do that and then click on next. And what you can see here is it's basically OpenStreetMap. So this is the fundamental data set that THERMOS draws on. It's freely available and it's global as well. So this is the important thing, that THERMOS can be used anywhere you are, because it can have access to OpenStreetMap. OpenStreetMap is not perfect. It can be a bit patchy in places. You know, it will miss out certain buildings. So if you want with THERMOS, you can use your own data and you can upload your own GIS files of buildings and roads, maybe where OpenStreetMap is lacking. But generally speaking, you can use OpenStreetMap to create a basic map and start to do an analysis. So yeah, as you open this, it defaults in London. So what you can see there is central London in Islington. And if you zoom in a little bit further, you can see the buildings come into view. And what I'm going to do is select an area that we're going to be interested in, and we're going to select that area to import as a map within THERMOS and have a look at potential networks there. So I've selected that, click on next. This is a sort of relatively new feature. This checks whether there's LiDAR coverage for the area that you've selected. Now, LiDAR is a data set which basically it gives you the height of buildings. It's not available everywhere, and it's very much up to the user to find out if there's LiDAR available for the area that they're interested in. It's sometimes not that straightforward to get hold of. In some cases, you have to pay a little bit for it. But the reason it's important to have it as far as you can is that it improves the accuracy of the energy demand estimates within THERMOS, because otherwise, if you're just using OpenStreetMap without LiDAR, it will estimate in a kind of two-dimensional model. So it just looks at the building footprint and the type of building. But where you have LiDAR, it will know the volume, the height and the volume of the building, and it can start to infer the surface area of the walls and the heat loss along with the type of building, and make assumptions as to the heat loads there. So in this case, there is LiDAR for this part of London available. And then lastly, before we create the map, we just have to set the heating degree days for the area that we're looking at. We've just kind of tried to automate this according to the location. So this is just basically, it's a weather correction for the location, depending on the climate there, to adjust the energy demands. And you can also set it here. It's just a way of THERMOS will group similar buildings along the same part of a street. It just makes the calculation a bit simpler, a bit less complex, if that's appropriate. We're now then ready to create the map. If I click on Create Map, and you can see here that that map is now being imported. So it's taking that data from OpenStreetMap, the buildings and roads, the geodata there, and it's undertaking calculations on those buildings to establish the heat demands. And you can see the map's now finished. And the next thing to do is to have a look at that map and start to create scenarios for networks. So if I click on HeatNet here, what we'll see is the main user interface of THERMOS. And you can see there, this is the area that we've selected and we've imported. So it's a it's a collection of buildings as polygons and row segments there. So I'll just turn off the satellite view just to make that a little bit clearer. And what we can do now is, for example, I can select, hang on a sec. That's better. If I can select all those elements, and whatever you've selected in this right-hand panel, it will tell you a list of information about that. For example, what we've selected here is we've got sort of 448 different segments of road pathways and 191 demands, so buildings. We can also look at the categories of all these elements according to OpenStreetMap. So we have, one place of worship at a church. We have 324 residential properties, for example. And also down here, we can look at the heat demand, the collective heat demand in terms of the peak in megawatts and the annual heat demand gigawatt hours there. You can see for that selection. So we're ready to start to just create a scenario to build a network now. So the first thing to do really is to select an energy center, an energy supply. So what I'll do is just click on one of these buildings and say that that's going to be my energy center. So what I'll do is I'll make that a supply point. And we now have to specify what that supply point is. And the bare minimum to do this is just to say, right, we're going to say it's got a maximum capacity of 10 megawatts. So you can put numbers in here. You can also put your costs in, but I'm not going to do that for this demonstration. The two minimum things is the maximum capacity and the cost at which that supply center can provide heat. So I'm going to put 3 monetary units per kilowatt hour there, say 3 euro cents in this case per kilowatt hour. And okay, and you can see there it changes color to indicate that that's now a supply rather than a demand. It can also be a demand, but we're just considering it a supply in this case. So the next thing to do is to look at the rest of the buildings and the routes and say, right, which of these do we want to consider? Do we want the model to consider the possibilities of making a network? And we can select different elements here if we want to. And yeah, just by clicking on them, you can, and again, you can see information about that selection in heat demand, heat peak, and also roads. You can select on the road segments as well, and it gives the length of it, for example. What I'm going to do is select all of it really, and we can then toggle the status of each of those elements. And there's three kind of status for those. If they're white, it means that they're not going to be considered at all in the network. If you toggle them to go blue, it means that the model will consider them as optional. The model will make up its own mind whether to include them in the network according to all the parameters that have been set. And if it's red, then it means it's mandatory, that must be in the network. If you wanted a building to definitely connect to the network, you can set its status as red. What I'm going to do is leave it as blue, leave them all optional for now. So we're almost ready to run. What we have is the supply and a whole bunch of buildings and routes to those buildings. There's a few more things to set in terms of parameters. I'll just quickly go through some of these. There's a left-hand menu here. I'll just go through the most important ones. First of all, there's 2 objectives that you can choose from when you're doing the optimization. First of all is where it just maximizes on the network NPV, net present value. So this is basically, it's maximizing revenue to the network operator. And the other one here is maximizing the whole system NPV. So this, the aim of this is to minimize the overall cost of heat. So it's a slightly different approach. And in this option, this objective, you can tell the model to actually offer insulation measures to properties, and also offer other alternative heating systems for buildings where the model considers it cheaper or more beneficial not to connect that building to the network. So there's two choices there. I'm going to leave it for network MPV for now. I'm not going to go through the rest of those. Just because of time constraints, I'll just quickly go through some of these others here. You can set tariffs if you're on a network MPV optimization mode, and you can specify connection costs. Importantly, you can specify pipe costs as well, and we have a table here with some default values in. So pipe costs according to the size of the pipe, and also so there's the cost of the pipe itself, and there's also what we call the civil cost of installing it. So basically soft or hard dig, as we say, you know, depending on the ground that you're installing the pipe in. Obviously that affects the cost if you're installing in a road rather than in a field, for example. But you can specify your own there if you want to. And you can also specify the heat transfer medium, whether it's hot water or steam. And we've got pumping costs down the bottom there. And then the last two main ones here, if you're on whole system mode, you can specify the insulation that the model will apply to some buildings. That's wall insulation. Typically, you can then specify the cost, and also the actual alternative systems if it's not connected to the network. Here, I mean, the technology itself is specified by what you put in these parameters, such as cost and emission factors as well. You can put in. It might be air source heat pumps, for example. This, I think, is that means gas central heating in this case. So you can specify your own there, what you want. So we are just about ready to try to optimize now. So what we'll do is we'll just name this and save it. And top right hand button, you can see optimize, and we'll click on network. And what it's doing now, it is optimizing. This can take a few minutes. But when it happens, there's this kind of script that runs that tell you what's happening. But what I'll do, if I can get to, I've got my bar in the way here in a minute. Right, that's better. Here's one I prepared earlier, basically. When it finishes optimizing, it would probably take about 5 minutes in this case, but this is what it comes up with. And you can see it's actually formed a network there. The sort of the brown elements are the network. So you can see the supply there, and it's supplying all these buildings. So that's what it thinks is the best option for that objective that we've set. You can see there's a map legend here, so there's a kind of a color code, so you can see exactly what's going on. The purple elements of parts of the network that can't be reached. Maybe there's breaks in the routes there. The yellow elements are peripheral to the network. They're just not needed, and the rest of it is really just not in the network. And we can just filter on the network itself, just to make that a little bit clearer. So that's selected the actual network elements now, and again in the right hand screen you can see what that consists of in terms of the number of paths, the demand, so the buildings, and also down here the total heat demand of that network. And you've also got the capacity, and the heat peak. So heat peak is obviously the sum of all the demands, but the capacity is the diversified demand, which is actually a little bit lower than the heat peak. So yeah, that's essentially the process of optimizing. Couple more things to just quickly mention before I finish. You can also optimize a supply. So this is a kind of separate process where it looks at the supply in a bit more detail, and you can specify like a time series for the supply. It looks at hourly profiles of heat, demand and supply, and also costs. And you can then specify technologies for that supply. And you can also, if it's a kind of CHP technology, include substations and also storage technologies as well. And then there's some objectives that you set around some financial objectives and options there. So setting up a supply problem as well, and then you can optimize on supply as you can with the network, but it's done separately. It's too complex to do both the supply and the network at the same time. So what it is, it's more of an iterative process to just kind of get the best match between the two. So yeah, just nearly finished now. Also to mention, THERMOS also does cooling. It's a much more basic model because just lack of kind of robust data really. But when you create a map, you can import it as a cooling map rather than the heating map. And also you can, down here, this is quite a useful feature where you can download a spreadsheet. So it will export all the parameters that you've put in and results, which you can then adjust according to what you're doing and edit, and then upload that again. And it just saves having to go through, if you're creating another scenario, going through the whole lot and updating all the parameters. It does that automatically. And you can also download a GIS file of the outputs and what you've created. And I think we're going to turn that into a geo package, which is a bit more of a useful, more of a sort of modern way of doing that. And finally, I should mention also there's quite a comprehensive help facility with THERMOS. We're in the process of updating that, but it does include the theory behind the models that we use. There's two main models, one on demand, energy demand, and one on optimizing networks. So yeah, please, if you do have a play with THERMOS, please have a look through that. There's a kind of introduction and quick start overview as well. And just finally to mention that we are, the last kind of bits of work that we're doing is around validation. So we're kind of just continuing testing of THERMOS. I just thought I'd show you this at the end as well, how THERMOS is rolled out. This map is showing all the registered users as of a couple of weeks ago, I think it was. We have 1,500 registered users across the world, actually. And between them, they've created over 3,000 maps. And this is the distribution of those. Each of those red dots shows a map that has been produced within THERMOS. So obviously, there's a lot in Europe, but interesting to know that it's being used in the US, in South America, and right away in Australia as well. So yeah, I'll finish there. That's the website, and yeah, email if you want to email the project. But yeah, we'll very willing to answer questions. If you need to email me directly or email the project, yeah, please feel free to do so. So thanks for that. Very quick whiz through THERMOS, but hopefully that gives you a bit of an overview of it. So I'll hand back to Jardo now, I think. to move on to the next speaker.
All right, thanks a lot for this demonstration. Simon, I give the floor to you again.
Yeah, thank you very much. Thank you, Martin, for this very interesting introduction. Let me just share my screen then. You should now be able to see my presentation. Perfect. Yeah, thanks again, Martin, for this very interesting introduction and for this hands-on on how to build up a heating grid with THERMOS. Now, if I may briefly introduce myself, my name is Simon Niesen. I work at the Münster University of Applied Sciences, and I'm project leader of the Task Force Wärmewende or Warmtetransitie or heat transition, whatever language you like most. I would now like to briefly tell you how the task force using THERMOS can help you and or your municipality to really tackle the heat transition, because that's basically what we do in the task force. We like to tackle the heat transition on a municipal level. Well, as you know, there are technical and market-driven solutions available. So the question really is, why are there so few sustainable heat supply systems, although the heating sector is responsible for vast amounts of CO2 emissions? One answer to that question is that very often municipalities lack the opportunities to address this issue and to address the heating transition. So our aim is to assist you and your municipality with using heat planning tools such as THERMOS, and on top of that, testing the use of virtual reality to really highlight the chances of a heat transition in 3D. Now, if you approach us, or if you approached us as the task force and ask where to start or even go on with the heat transition in your municipality, we would try to identify in a first step potential projects or potential project areas where heat networks already make sense today. Those places are usually spaces where there's a heat or a high heat demand, a specific heat demand per area. So to find those areas, we would use GIS tools such as our heat navigator, which you can see a screenshot of on the right side here. There are other tools like the Heat Map Project Europe and the Energieatlas NRW or the Warmtetransitie in the Netherlands. And we would use those tools to identify places with a high specific heat demand, while considering other aspects such as building types and the type of ownership, so private or public ownership, and some other aspects. That way we then can decide on which area we should focus in a first step. After that, we would use the THERMOS tool together with you and your municipality, and then create a project as you've just learned how to do for that specific area. And we choose building types and potential heat sources that should be in the network. We would then within THERMOS carry out a first analysis that can also include configuring alternative decentral heat sources in the buildings. And we'd set up some potential heat supply scenarios. The main benefit of this procedure is that you can very quickly obtain initial results as a basis for further and more detailed planning with engineering offices, for example. The task force would then provide the main findings of the THERMOS simulation or the THERMOS calculation within a clear dashboard that should or that could look something like that. And this dashboard can be used as a basis for further discussions within the municipality or with external stakeholders. And it can also, or it does also allow for a quick and easy comparison between different project approaches. So we could really play through different scenarios, which buildings to include, how to set up the heat supply, and make all those scenarios comparable to each other. Afterwards, the results can be used as examples for other parties and as best practices for other parties. That's also something that other parties can really profit from your findings. And the last step would be, after all those calculations and after setting up those dashboards, we would create a 3D model of the project area if necessary, or if wanted, because we have a project partner that is Ron 3D in the Netherlands, that specialized in building 3D models of municipalities, of such projects. And you can see here on the right side some examples, for example, a PV park or seasonal heat storage. That way we can visualize different solutions and different project scenarios, and we like to do that because we think that visualization brings the benefit of acceleration and support of communication and further planning in politics as well as in public. So building such a 3D model of a district heating project may really facilitate the understanding of the project, and that way reduce barriers. For example, some people might have might not really want to have such a huge seasonal heat storage in their municipality. So we could, with those 3D models, visualize how it can be integrated into the landscape. And again, we'd like to share those results as well as best practice with other parties. So to sum up this very brief introduction of what we can do with applying THERMOS to your municipality, let me once more tell you what we think the steps are that need to be taken to get to a sustainable heat supply. First, you and we would need to explore the current situation in your municipality and identify the potential for sustainable heating by making use of the opportunities and tools that are already and often freely available. We would connect relevant municipal or other stakeholders and get one step closer to a sustainable heat plan, because all those actions show your will to become sustainable in heat supply. That's basically what I wanted to say. Thank you very much for your attention. And I would now like to hand over the microphone to Rita Erik from the German Energy Agency, who will say a few sentences about the relevance of THERMOS in the context of heat planning in Germany.
Thank you, Simon. And also, Rita, it's wonderful to have you. So I'm very much looking forward to your perspective, as you have accompanied also the project and the process of the development of the software since the very beginning as a senior expert, particularly focusing also on renewable energies, so to say, from the German Energy Agency, DENA. Before you start, Rita, let me remind everyone to please post your questions into the chat. If there is time, we would like to answer at least some questions before we go into the breakout session. Over to you, Rita. Thank you.
It seems like Rita somehow is thrown out of the session. I can't find her anymore.
Me neither.
So maybe we start with the questions.
Then we start with the question, indeed. Thank you. And please let me know when Rita is back. So, Martin, there has been a question concerning the selection of when you create a map, at what scale would you select an area? Should it be an area, or could it be a small city as well? That was a concrete question here.
Yeah, good question. THERMOS is scalable up to a point. The constraining factor is the computation time, really. So if you're selecting a whole city, it could be there for days working out all the options for the network. You've got so many different buildings and so many different routes that, yeah, it's almost exponential, the time as the number increases. So, and it's not very often that you would actually use THERMOS in that way. There's different techniques. If you're looking at a kind of whole city, there's a different way of doing that, and it's something that we're looking into, actually applying a slightly different methodology where we're zoning a city, doing heat zoning, and we're working with BEIS, which is the UK government department, that's Business, Energy and Industrial Strategy, BEIS. So we're working with them in producing a methodology for this. But in practical terms, you can select, I mean, you saw what I selected in the demo. You can go, bigger than that. I don't know in terms of how to quantify it really, but you can do 300, 400, 500 buildings maybe. That does mean quite long computation times. It could be hours, it could be a day or so, but it will do that. But it's more complicated. But so the smaller area that you're selecting, the quicker and more easier it will do it. And I should also say that when we launch this version after March, at the end of the project, so the public free access version, we will have to put a constraint on that with regards to how users can use that, because it just, otherwise I think we'll be heading for problems if lots of people then start selecting a whole cities to analyze. Yeah, so I hope that's answered your question.
Yes, thank you, Martin. And then there was another question concerning what kind of heat sources can be integrated. Could you elaborate further on this?
So that's it. You can define the heat source, basically, any heat source you want. It just depends on specifying the parameters for it. As I said, the basic optimization of a network where we just set a supply point, and you can just define that in terms of its maximum megawatt capacity and the cost of the heat. But you can also specify how that cost is made up, whether there's a fixed cost and a cost per kilowatt, for example, and the emissions. If you're looking at the supply optimization, as I said, where you're looking at the supply in more detail, then you just specify, for example, the lifetime of the plant, whether or not it's kind of CHP enabled, so combined heat and power, its capacity, the efficiency, and the costs. So it could be any kind of technology. It's just how you define that, how you specify it, really, and THERMOS is able to accommodate that.
Yeah. There's another question. How does THERMOS interact with heat sources you want to attach in the buildings connected?
With heat sources?
Yeah.
So you can specify a number of heat sources. It does make, again, it a little bit more complicated. You can specify more than one heat source. And what I actually, as an aside, what I didn't demonstrate is the fact that you can also draw quite easily on that user interface. You can draw in a new heat source or a new path. So if you wanted to add a heat source, which wasn't shown on the map, you just put a blob on there, and you can specify that as a heat source, and then connect a line to the nearest road, and that forms part of the network there. But yeah, again, you would then have to you would, if you were talking about a heat source in a building, you would have to just specify that heat source in terms of those parameters that THERMOS understands.
Yeah. And is there any possibility to select the temperature level of the DH network?
There is. There's some defaults of the supply and the return that THERMOS comes up with, but you can adjust those. Yeah, the supply and return temperature.
All right. And is there a connection of temperature level to the heat sources applied? The cost of the civil engineering and the cost of the operation and the cost of the heat supplied?
Connection of the temperature level to the heat source. I'm not quite sure whether I think I might have just kind of covered that. It's so if you've got a number of heat sources, you just specify what those are. The temperature is really dealt with in the network optimization. As I said, you know, the flow and return temperatures, that's where you consider the temperature of that heat source. And yeah, in terms of the costs of the engineering and operational costs, you can specify those. So costs are made up of, as I said, it could be a fixed cost. Then on top of that, it could be a cost per megawatt or a cost per kilowatt you apply, and the cost of the heat supply. So that would be in, you know, cents per kilowatt hour, for example. So you can specify that, yeah.
And I see the questions are popping up, so that's a good thing. Is it possible to combine heat and cooling supply network / demand like working with heat pumps or similar? Or is that too smart for the beginning?
It's a bit too smart for THERMOS. As I say, you can optimize a cooling system, a cooling network, but it's done separately to heating. THERMOS is not able to do it simultaneously and to combine that, so you have to do it separately. Again, it's just complexity issues that's the constraint there, really.
Yeah. I think this is going to be the last question for now. Can solar district heating be integrated?
Sorry, could you say that again?
Can solar district heating be integrated?
Solar heating.
Yeah.
As a heat source, you can specify that. Yeah. To the extent, again, that you specify the set of parameters that THERMOS understands, and you can introduce some storage to that as well, which obviously is associated with solar thermal systems. So yeah, it's, as I say, the supply technology is fairly neutral with THERMOS. It's all about how you specify the parameters of that energy supply source.
Thank you very much, Martin. I think I actually took note. There are other questions which we may take then eventually also in the Q&A session further to come. Now, since also Rita, if I'm not mistaken, hasn't been able to rejoin us, I would suggest we are going now into the breakout session where we would like to discuss with you the possible application that you see from your perspective within your professional life for THERMOS. So I hand over maybe to Christian to tell us more about how this functions. Oh, to Thiago.
Yes. Simon, do you want to tell something about this?
Yeah,
so,
I've just shared my screen again.
Okay.
So maybe I can just briefly introduce on how this breakout session should work. We'll now split all of you participants up into 2 groups, and you basically get 2 questions from us that we'd like you to discuss within this group or within those groups. And the first question after introducing yourself would be in which case you can use or in which case you can imagine to use the THERMOS tool at your place or your place of work, and what questions do you have about the use and operation of the THERMOS tool, and what do you need to be able to use the tool. We will also send those questions into the chat of the respective breakout rooms, and I think for now, Christian, you can just start the breakout sessions, and you will be automatically sent into those rooms. We had quite the interesting discussion as well. We talked about questions such as how precise the heat demand forecast is. And Martin told us that in the worst case, he think that the error would be 50%. Yeah, that's the very worst case. But usually the error should be below that. Yeah, talking about the first question, we didn't really get to talk about the second question, but talking about the first question, how people can imagine using THERMOS at their place. One answer was, so there are regional energy strategies in the Netherlands, and the mapping options and the visualization of options of THERMOS can really be used to let locals participate in the heat transition or in the regional energy strategies. And also in the Netherlands, they have the comfortable situation that they have lots of demand data available for the buildings, I think on postcode level 6, so usually clustered into groups of 10 to 30 houses. There's energy demand data available, and that can be used within the THERMOS tool as well, and make the actual forecast of the district heating system much more reliable and much I think much more reliable, puts it. Also, we had the answer to use THERMOS to really collaborate with other people within THERMOS projects. So to get together different stakeholders and to get them to work together on one single project. We got the answer to help municipalities by getting started with the heat transition. Yeah, I think that were basically the answers we found, and I think that would be the sum up of those 2 breakout sessions or those 2 breakout rooms.
Thank you very much. I think we still can use the time to answer some and clarify some questions, but maybe first let me react quickly towards Martin's humble validation response of 50% accurateness in a very extreme case. As I said, from it, the University of Aalborg, for instance, has validated THERMOS against an optimized case which was already optimized and compared it, and by that found that the difference between THERMOS optimization and real life optimization was up to 90% matching. So within this range, I guess THERMOS can be seen in some cases much better, in most cases much better than 50, which is the extreme case. Having said that, there was a question previously concerning, and here I would like to include Martin in the response. Does the model calculate results on an hourly basis or on a whole year basis, like pressure drop, etc.? It's a very technical question, but maybe you have the answer.
Okay, thanks, Carsten. Yeah, so network optimization, it doesn't consider hourly figures. All it understands is peak demand and annual demand for the buildings in question. It's only when you look at your supply and you're optimizing on the supply, that's when you can start to define a profile for the heat demand on an hourly basis. And you can set different profiles according to a building type, a generic building type, such as, you know, residential buildings. You can set that profile, how the heat demand might vary across a 24-hour period. And then, yeah, the model will consider that in terms of the energy supply that you've specified and any storage, and how all that interacts to meet that demand. So yeah.
Yeah, thank you, Martin. And then there was is a question we hadn't the time to look much into, also the optimization, how you can prioritize different outputs. You, for instance, can prioritize via costs, but you can also prioritize CO2 emission savings. And in that sense, by the way, this was a demand formulated by our cities who were part of the developing the software here. Here a question concerning this. Concerning the CO2 savings emissions, how are those emissions are quantified? On which databases are they quantified? Again,
it's user specified, so you can specify emissions. Again, if you're optimizing on the network, then you just specify emissions limits in terms of carbon dioxide. You can also look at emissions limits for particulates. I don't know if you're familiar with the term PM25s, what we use in the UK for those dangerous, these small particles that can cause health issues, and also NOx, so NOx, you know, nitrogen dioxides. So you can specify those, and both in terms of cost, so cost per ton, for example, you know, the cost of those emissions that you might want to consider in that way, or in real terms in the actual amount, you know, tons per year of emissions. So it doesn't draw on any kind of established figures. It's user specified. And one thing that we're focusing on in the last few weeks of the project is to explain in the help, the online manual, try and give more information on the defaults that the parameters that the tool suggests or offers, and guide the user on where that came from, and maybe signpost to further information. You know, because we realize, you know, sometimes it's difficult to get hold of that information, where to go and what to use. And if you're just using the THERMOS default, you don't know if it's how valid that is for your particular situation.
Thank you very much, Martin. I understand now we are handing over to have a final exercise with everyone.
Yeah, thank you. We will now have a really small feedback round. So I think there will be just a short survey popping up on your screen, and we'd like to check the answer that is most fitting for you. Christian, if you could start the survey.
So we have 7 of 12 answers. Okay. I think the remaining 2 answers are from our project teams, so maybe they won't. Okay, then I should show you the results. So most interesting seems to be the self-study and self-guided use, and that's also I think what THERMOS is has sort of, because you have a good documentation and you want to let everyone learn this your tool, or give everyone the possibility to learn your tool on himself. And also you are interested in getting support by using the software, and even maybe that we can develop the case for you. And I think that's one thing we would really like to do. So please feel free to contact us, and so we can help you and develop a case together with you. So I'll hand over to Simon. Do you want to do the closing words?
Yeah, thank you. Yeah, that's basically it. That's our workshop, our webinar. Thank you all for participating and attending, and really giving us a good overview of at first what the THERMOS tool can do, and also what you as the participants of this workshop are most interested in. I think there will be other times we'll meet again, and maybe in just one small question I have for Carsten or Martin. What will happen to THERMOS after March?
Maybe I come first, and then I hand over to Martin as the project coordinator. So from our perspective, what I can say, what we are still doing this month is to release a comprehensive capacity package, so to say. We are also restructuring the website so that you can easily have all the material available, the latest material available for you to self-study, but also to find the possibility to work with others, contact other organizations that are near to you or are important for your case that you would like to develop. And last but not least, we are also going to publish as we said, it's an open source software. We are publishing the code of the software for you to develop if you want to. Otherwise, we also have the plans to develop THERMOS further. And by that, I hand over to Martin.
Thank you, Carsten. Yeah, and I guess just to mention that we've one of the outputs, one of the deliverables of the THERMOS project was to produce a business plan of how we take THERMOS forward and make sure it becomes a lasting legacy. And so the way we foresee it at the moment, we're still finalizing this, but we're looking at a kind of 3-year period ahead, and we're committed to maintaining a free version online, web-based version for everyone to use. As I said, there will be some limitations on its use, but it will be as fully functional for most applications in that case. But we will also be offering a service, a fee-paying service for people that will be using it in a more sort of maybe a more commercial setting where they need the full functionality in terms of running very big jobs. And what we'll do is we'll allocate a specific server resource and offer full technical support in that case. So yeah, basically two options there. There's the free version, and then there's a more comprehensive version, which there'll be a fee for with technical support. And obviously that income will then be used to look at developing THERMOS further as we go forward. So that it very briefly is the way we're going with it.
Thank you very much. So I'm very glad that THERMOS won't be shut down by the end of March. And perfect. Yeah, again, thank you all for participating. Thanks, Carsten. Thanks, Martin, and all the others. That's it. And I hope we see again. Again, we have other webinars starting, I think, 2 weeks from now. And I think if you registered, you should be getting an email from us with all the details about the other informations. Thanks again. Have a nice day and take care, and hope to see you very soon. Thanks very much.
Yes, thank you. Bye.
Thank you. Goodbye.
Thank you.